before we get started, we need to go over a few safety rules. Remember, safety comes first in everything that you do. Be sure to wear your hard hat, safety glasses, cut gloves, and sturdy boots. Inspect your hard hats for any cracks or damages. You also want to take a look at the date inside. Make sure that the hard hat is not expired. We want to check the ratcheting, and we also want to twist to see if it cracks. Please also check your gloves. Make sure they are not ripped and torn and the coating is in good condition. If your gloves look like these, we need to go ahead and replace them. With your glasses, make sure they are clean and scratch free. These again should be replaced by the foreman. Look at the bottom of your boots and make sure they still have quality tread life left, and see your foreman if any C. Davis issued items need to be replaced. Remember, the topics covered in this video can't cover all the areas or foresee all variances. This should only be used as guideline and not as a complete set of safety rules. There can always be special job-related safety requirements that cannot be covered in this video.
Greeting viewers, my name is Christian Cabrera. I'm an 11th year journeyman electrician. I work for C. Davis Electric. I'm going to show you a quick review of what a normal standard electrician should have on the site. First, I'm going to start with a multi-ratchet screwdriver, long nose trim screwdriver, flathead, lineman's pliers, strippers to connect and strip your wiring, standard pair of channel locks, standard pair of dikes or side cutters for cutting wire, an MC roto splitter, which I'll show you in the next segment how to properly use one for cutting MC, a torpedo level that's magnetic, standard pen tester to check for voltage or read voltage, a couple bits for your drill setup, multi nut driver and an extension magnetic bit, utility knife, and a marking tool, pencil, marker, any of your choice. I like to have a nice sturdy belt, something above the waistline, padded, holds a lot of weight. I use a tough belt. It's got a connecting system for your different type of bags and tool belts of your choice. And also a standard drill, impact, something that you can torque down screws when needed. A magnetic pouch, I want to say, that helps kind of keep your, your hardware together. That's a standard tool belt for an electrician. Welcome back. In this segment, we are showing contactors versus starters. Contactors are one of the most common and widely used devices in the field of power distribution. A contactor is an electrically controlled switch. People use it for switching an electrical power circuit. A contactor is used to control many devices like electrical motors, lighting, heating, capacitor banks, thermal evaporators, etc. A starter is a kind of device or motor which is electrical. It controls the use of electrical power to equipment. As the name implies, a starter starts motors. What is the difference between the contactor and a starter? Since contactors and starters both control electrical motors, people usually use the two terms interchangeably. What are the features that make them different? A contactor is an electrically controlled switch similar to a relay. In comparison, a starter is a contactor with the addition of an overload relay. A circuit applies voltage to a coil to close the contacts and to supply and interrupt power. On the other hand, a starter uses overload relays to protect the motor from load surges by shutting it down. This also prevents overheating. And that's the difference between contactors and starters. And now I'd like to show you a physical example of a lighting contactor. You have a 60 amp square D. You want to start with your line side wires coming to the top. Your load side wires will be the circuit that you're controlling on the bottom. You have your latch and unlatch terminations with your common. This is a mechanically held contactor. Electrically held, you have the same application of line on top, load on the bottom, but instead of an unlatch and a latch wire, you only need a 120 circuit to control the contactor. Here's an example of a motor starter. Same thing, line on top, load on the bottom, but now you have heating elements that help the overload protection of whatever it is that you're controlling, whether it's a motor or anything that requires a winding belt.